Last session before lunch is around the small hive beetle. We obviously do not want it in this country, and we are here to learn more about it from Dr. Ashley Mortensen. She is a senior scientist at the New Zealand Institute for Plant and Food Research, and her research focuses on honeybee behavior and biology. So please join me in welcoming her to the stage.
Kia ora. Ko waikato te iwi, ko waikato te awa, ko rorokura te wahi mahi, te arawa iwi, tena katoa katoa. So, kia ora, welcome everybody. I'm Ashley Mortensen. I'm going to talk to you guys a little bit about small hive beetles. And so there's been a bit of talk today about or this weekend about some of the biocontrol efforts that are going on in New Zealand. And the small hive beetle that you can see right here is one of the adults over here on this slide, and the one behind me, I'm sure, is what we would see as an adult small hive beetle in a honeybee colony. And so they are distributed pretty broadly now. They started out in Africa here, in the sub-Saharan portion of Africa, and were identified in the United States in 1996, and then have been identified in several other regions since that time. They have been in Australia since about 2001, but you can see we're still sitting unhighlighted on this map, fortunately, and we'd like to keep it that way. So MPI actually, is a part of their bee pathogen program, has small hive beetles as one of the items that they are monitoring and looking for when they're out in these apiaries doing inspections for bioprotection. So part of why I'm standing up here talking with you, because I'm not part of MPI and I don't currently do small hive beetle work, but I have just recently moved to New Zealand to join Plant and Food Research. So I've been here about a year and a half now, and prior to that I was a graduate student in the University of Florida Honeybee Research Lab, which is located here in about the middle of Florida, and then prior to that I was a hobbyist beekeeper in South Carolina, which is just a little bit further north on the east coast of the United States. And so I actually have a fair bit of experience dealing with small hive beetles in my own hives. And then my advisor, the professor that I did my PhD work with, most of his PhD work himself was in small hive beetles. So we always had a few side small hive beetle programs going, and then researchers from around the world coming to our lab to do small hive beetle work because we had such great access to small hive beetle populations. So there's 4 life stages of small hive beetles. They're similar to butterflies and other beetles and regular flies where you would have, or in honeybees too, right? Where you have an egg, a larvae, a pupae in the adult stage. The ones that are easiest to see in the honeybee colony are those adults, so that's the beetle that we see here, and then the larvae. And usually these much later stage fatter larvae are the ones that you can identify in your colony. And so these larvae can actually be pretty gross if you have a pretty large infestation in your colony. So you can end up with combs that look like this. So this is a brood comb that has some quite developed larvae on it. There's some frass over here, so that's the feces of those larvae. And then they also produce a slime. So this is that liquidy, slimy bit that you see here, and it's a yeast liquid, and it makes a nice smell that says to other small hive beetles, we found this amazing place, you should come hang out here, and it attracts more small hive beetles into that colony. So this is a really fun time lapse here of some combs that I actually had brought into an incubator for one of my projects in Florida. I needed to hatch out brood, and so they had been unprotected from worker bees for 48 hours, and in that time these larvae hatched out, and it's a time lapse, so they're not quite this fast. But these are 2 to 3 day old larvae that are wriggling around on a comb because there weren't any worker bees there to attack them and catch them as they were hatching out of the eggs. And this was actually out of a colony that was quite strong, really healthy looking. It was a research colony that I was using for my projects. But as soon as those adult bees were removed, that underlying small hive beetle population that was being suppressed by the workers was able to do really nicely in the laboratory. So as I've said, small hive beetles are in honeybee colonies, but they're not an obligate pest of honeybees, which means they aren't required to live in a honeybee colony. They are able to survive in laboratory studies on fruit and on flowers. They've also been found in bumblebee colonies and produce that similar slime-smelling substance that attracts more small hive beetles and bumblebees. But they do really, really enjoy honeybee colonies. They do really well, and that's where we find them as a nuisance as beekeepers anyways, and have the most impact from small hive beetles. So I wanted to take a second to talk through the life cycle. As I mentioned, you'll see these adult beetles in your colonies, and so they fly fairly well. They're able to disperse, and they'll find a beehive, and they'll come in through the entrances, and they'll go ahead and lay eggs on the wax cappings on the comb. Those eggs can take anywhere from 1 to 3 days to hatch out. And oftentimes those new hatching larvae are going to be suppressed by the bees themselves, and even the ability to lay eggs would be suppressed by the bees. But if those larvae hatch out and they're able to find a little reservoir that's nice and safe and unprotected, they can mature fairly quickly, just around a week, maybe faster or slower, depending on how much protein they can find to eat. And that protein often can be in the place of pollen within your colony. And then they'll go ahead and, once they're in that late stage larval phase, they're going to actually crawl out. So this is called the wandering phase, and you'll see these larvae crawling out. Well, you often don't see them crawling out of the colonies, but in laboratory studies, you'll see them crawling out from where they were eating pollen to move and find a sandy substance. And these wandering larvae actually can live for up to 2 months, they've been observed, that are still out looking for a place to pupate. So they dig down into the soil, and they become this really cute little pupae here, who's like sitting there with his little wings wrapped up. And they sit down in the soil for about 3 to 4 weeks. And at that point, they'll emerge back out as adults and go back in and reinfest a colony. And those adults can live up to 12 months is what they think out in colonies. In the lab, it can be about 16 months that these adults can be living in colonies and reproducing eggs and continuing this cycle. So the bees themselves aren't super keen on having small hive beetles in their colony. So the small hive beetle has this really strong exoskeleton, and it's able to protect itself from being harassed from bees. As it's running around through the colony, these bees are actually chasing the small hive beetle and giving it quite a hard time. It's able to hunker down and pull its legs and its antennae in underneath its exoskeleton and kind of handle some of that attack and stay quite safe for it. As the bees, I think this one, as it runs across, one will actually dive on top of it and hold it there and be trying to attack it quite well, but they can do pretty good at defending themselves. But they don't like to be hassled this much either, so they really prefer to find somewhere in the colony that the bees cannot access. So they find these small nooks and crannies in and around. So it's really common to see them along the edge of these hive bars. When you open up a colony, any of these little grooves, you'll find small hive beetles tucked in there. And the bees are quite pleased to have them hidden somewhere, so they'll start to build these little propolis walls around those areas. And so this is an observation hive that has these special cutouts. And you can see quite well that they've built this propolis in what they call it actually is a prison around this small hive beetle, and they imprison these small hive beetles. And European bees still do this. African bees do it much better, and that's because they've had much more time that they've been living with small hive beetles than European honeybees have. But European honeybees still express this behavior somewhat. And whenever they have these in the prisons, as beekeepers, whenever the first time I ever heard about these prisons, I was like, fantastic. They'll just wall them off, everything's great, they'll go ahead and they'll die inside of there. But the small hive beetle is, again, really tricky and has figured out how to use its antennae to stimulate the mouth parts of the honeybees. So as the honeybees are sticking their heads in there to check on those small hive beetles, the small hive beetles actually recruit them to feed them as if they would another honeybee. So this beetle here and this one actually both get those workers to give them a sugar syrup feed, and they maintain those small hive beetles when they have them in that space by being tricked into prophylactically feeding them. I'm gonna cough, sorry. So one of the ways that we can exploit this behavior where they want to hide into these narrow nooks and crannies is the utilization of some mechanical trapping. And so this is a fairly standard looking example of a beetle trap. And so in this space, there's a little reservoir that drops down. The bees can't fit through these cracks, but the small hive beetles can. You can put a little bit of mineral oil inside of there, so when the small hive beetles go down in, they'll drown. And then you could add a little bit of apple cider vinegar, and that actually attracts the beetles into the space. However, if you are a beekeeper like me who is just so used to taking off a super and setting it on its side and don't think about those small hive beetle traps being in there, it's really frustrating when you dump mineral oil and apple cider vinegar down the side of your frames. But for the most part, this is pretty much exclusively what we did for small hive beetles in the University of Florida apiaries. We ran these traps and we just maintained strong, healthy colonies. It was our primary mode of defense with small hive beetles. There are some chemical controls that are available, but they have moderate success and aren't broadly used. One of them is Checkmate, which is coumaphos-based. It's available in the United States, but it's not widely used, and it's not the favorite chemical class to use in a honeybee colony. And then GuardStar is like a topical pyrethroid that you put in the dirt, and so it's actually trying to thwart that pupal phase, but it's very difficult to actually treat a wide enough portion of ground because those wandering larvae can wander for 2 months, so they can cover quite a bit of distance. And then some of the biological controls that have shown limited efficacy that people are still interested in and talk about are chickens. So if you have chickens running around your beehives, maybe they're eating some of those wandering larvae. And then nematodes, but there's some evidence that shows that nematodes aren't working, so there's some evidence against nematodes, even in addition to just not evidence that it is working. So really, it's more the cultural control. So these are the things that we can do as beekeepers to just limit the chance of small hive beetles becoming a problem in honeybees in the United States. And so one of the things that we do is make sure that they have a strong enough colony that's occupying all the combs that you have in your colony. So you don't want to go ahead and put 3 supers, especially that have dark comb, on top of a colony that's really only going to be able to defend the bottom 10 frames. If you have a whole bunch of space that's being undefended, especially if it's a brood comb or has pollen in it, that can become problematic with small hive beetles. Also, when you're pollen feeding, if you put more pollen patty than can be consumed in about a week on top of a colony, and you have that smashed down tight between 2 boxes, the bees can't defend that space from the small hive beetles. So we typically just use a riser and then use enough pollen that we know will be consumed in that quick amount of time. And then when you have your whole apiary and you're thinking about management of all your colonies, you want to be sure and remove deadouts as soon as they occur, which is a good recommendation anywhere, but it becomes really important when a deadout frame within a few days can start to have this going on. And so this essentially trashes this comb, and you have to destroy all of this after just a few days of it being out there without any bees in there to protect those resources. So the big thing when I came to New Zealand and first started going through honey packing or honey extraction facilities was that there are all these hot rooms, these rooms that are maintained at 35, 36 degrees, low humidity, and there's tons of supers stacked up in there, and they might be in there for several days, for maybe a couple weeks before they get extracted. And it struck me as something I hadn't ever seen before, and I realized part of that was because of small hive beetles. So in the United States, honey is extracted or frozen within about 48 hours of removal from the colonies. And that's because you small hive beetles will start to slime the honey on the combs. And this becomes fermented honey, and even the bees themselves won't consume it back. So this is really the biggest thing that stands out in my mind, that if small hive beetles were to establish in New Zealand, would be something that would change significantly how things are going. The good news in the story is that whenever there have been some studies done recently that have looked at the reproductive success and the survival of small hive beetles, and they don't do well in cold temperatures. So if you're in an area that's quite cold, you have really low survival, and the development time is really slow on them. And so this is why I'm from down here in the southeast of the United States. It's quite warm. Small hive beetles do really, really well, and we just deal with them chronically. We had a grad student that came to us from Oregon, and this is, we're fairly climatically similar in New Zealand to this part of the US. And we had a grad student that came to us from Oregon, and he was like, I thought like small hive beetles and problems from them was a fairy tale. I've never seen a problem with small hive beetles. I didn't think this existed. So right now we're sitting nice and pretty in this area where if small hive beetles were here, they're unlikely to establish at a rate that they're extremely problematic. But obviously with global warming and climate change, those things can change over time. So it is something that we need to continue to be vigilant about. So I want to thank the University of Florida. So Jamie Ellis helped me put together some of this and make sure that everything I was saying about small hive beetles was completely kosher. And then Brum from the Netherlands, so Wageningen University helped me with some of the images that I use throughout here as well. So with that, I think I have 1 minute for questions, and all of you guys probably want to go eat. So.